Hi, future doctors. Welcome to the next class. From now onwards, we'll discuss properties of solids from first year. So, properties of solids. So, all substances will be divided into three types: solids, liquids, gases. So, in that we are discussing about solids. Again, liquids and gases, those will be coming under fluids. That is our next topic. So, what are the properties of these solids? Some objects, whenever you are applying some amount of force, it is changing. It may change its shape. Let us assume this is the book. So I am bending like this. Then it is changing its size and shape. If I am removing this force, so it is regaining its original position, isn't it? Same like that. If you are taking any object like this, you are applying some amount of force on this. So then it is going to become like this. Its size and shape is changing. Whenever its size and shape is changing, so this force we will call deforming force. Now you are applying so on that object deforming force. Whenever you are removing this deforming force, again if it is regaining its original size and shape, that is having elastic property. That is only elasticity we will say. It is having elastic property. Whenever deforming force is removed, then object is gaining its original size and shape means it is having elastic property. After removal of this, so this object is like this one. It is not going to regain its original size and shape. That is called plastic body. So elastic, plastic. So we'll discuss in this more about elastic nature. So whenever we are applying force, its size and shape is changing. So like that, if you are taking a wire of length L, area of cross section A. So if you are applying force perpendicular to the surface area, normal force we will call. Then let us assume its length is going to increase. If length is going to increase, its size and shape is going to be changed, isn't it? So at the time, this object is having strain. It is under strain. Then what we applied means on this object stress. Hooke's law. What Hooke's law said means stress is always directly proportional to strain. What is this stress means? Force acting on the particular area is directly proportional. What is the strain means? Change in dimension. Change in dimension by original dimension. Change in dimension by original dimension. In this case, length is changing. Initial length is L. Final length is L dash. What is the change in length means? Delta L. So delta L is nothing but change in dimension. L is nothing but original dimension. This is called strain. If length is changing, that is called longitudinal strain. If length is changing by applying stress, that is called longitudinal stress. So again we will discuss that. But here in Hooke's law, stress is always directly proportional to strain. But for this you will be having limit. That is only within the proportionality limit they are going to say. So within the proportionality limit, stress is always directly proportional to strain. What is the proportionality limit? How we will be coming to know? We know spring very well. So if you are elongating spring, it will be elongating. If you leave that force again, it is going to gain its original size and shape. But it is gaining now like that. If you apply suddenly like this, then it will not regain its original size and shape. So you have crossed that limit, isn't it? So we should not cross the proportionality limit. If it is crossing means this is not directly proportional to strain. So Hooke's law, Hooke said within the proportionality limit only, up to some limit only, stress is directly proportional to strain. So if you remove this proportionality, you will write one constant. That is only we will call modulus of elasticity. E is equal to stress by strain. In this lesson, we have to write these terms fully. No symbols for this, stress by strain. This capitally we are calling it as modulus of elasticity. What is the unit for this means? Stress units, Newton per meter square, F by A. Strain units, centimeter by centimeter, meter by meter, otherwise meter square by meter square, meter cube by meter cube. Therefore, no dimensions for strain. So, Newton per meter square means mLt power minus 2 by L square, mL power minus 1 T power minus 2 equal to pressure dimensions. So, that is about modulus of elasticity. So, depending on applied stress and strain, so we are going to get three types of modulus of elasticities. So, first one is Young's modulus. So what is this Young's modulus means? Longitudinal stress. So you are applying force on this area of the wire like this. This is the area. If you are applying force on this area like this, then it is going to be elongated. So longitudinal stress by longitudinal strain. So F by A by. Then what is the longitudinal strain means? Change in dimension by original dimension. Delta L by L. So y is equal to. So this one only they will write FL by delta L into A. This delta L only we will call it as elongation E. So therefore, in place of this delta L, they will write E. E A. So this is the Young's modulus equation. 90% they will ask problem from Young's modulus only. We will discuss almost this Young's modulus only in different cases, how they are going to ask. Next one is bulk modulus. Bulk modulus is going to be defined as stress by strain. Which strain means volume strain. So volume stress by volume strain they are going to say. If you are taking any object like this, this is the original volume. So this object we have placed within the water or liquid, then its volume is going to decrease like this. So this is nothing but delta. Volume decreases means minus will be coming. Simply sponge will be there. That sponge if you press like this, so volume is going to be changed. Volume decreases. Therefore they will write minus delta. So volume stress by volume strain. This F by only they will call pressure. PV by delta V. They will write minus. That is called bulk modulus. So either Young's modulus or bulk modulus or next modulus. All the units will be same. M L power minus 1 T power minus 2 and units Newton per meter square, dimension formula for all those same. Next, reciprocal of this bulk modulus, that is only compressibility they will call. So dimension formula for compressibility, reverse of this M power minus 1 L T square. So negative dimensions in mass. So after gravitational constant, you will be getting for compressibility, and next another one will be coming, we will see. So negative dimensions in mass. Next, rigidity modulus. Rigidity modulus or shear modulus they will call. Shear modulus. Shear stress by shear strain they will call. That is also F by A. So how you will get shear stress or shear strain means, so this is going to be parallel, you are applying force like this. See, this is going to be shifted like this. How much angle it is going to be rotating, otherwise how much distance it is going to be shifted. So we'll see here, this is going to be A, B, C, D. So whenever you are applying force on this area, it is going to be shifted. B is shifted to B dash, C is shifted to C dash. How much angle it is going to be shifting. So now you have seen. So this is going to be here, it is going to be shifted at top end. Bottom end remains here only. So it is going to be shifted by applying force on this area. Isn't it? So this shift is nothing but this theta is going to be x by L. Therefore, rigidity modulus or shear modulus. So, F by A by theta or F by A by theta is going to be x by L. Shear modulus they are going to say. Isn't it? So, this modulus you will be getting whenever you are tearing the paper or you are folding the paper. So, you are going to get shear modulus. So, these are about three different modulus from modulus of elasticity Hooke's law. So, this is about elastic and plastic bodies how we are going to call. So, if it is regaining its original size and shape, So we are saying that is elastic body. If it is not gaining, that is plastic body. So if you remember these three formulas, you can solve problem. So next class onwards, we will discuss only on this Young's modulus, how they are going to ask different problems. So this one you can practice. So we will see next class remaining definitions.